right, so this is the video key for the part 2 for June 2024. So for the first one, if we take a look at this, there's X's and I's here, so you have to actually work this out. This is not something that you can put into the calculator. So we are going to go ahead and do order of operations here, which says you have to do multiplication, and then we're going to add this 2x squared I to it. So for multiplication, remember that we're doing FOIL. So first, that's x times 3 is 3x. X times negative 2xi is going to be negative 2x squared I. And then we're going to do the inner. So this is plus 6i. And then we're going to do the last. So this is going to be negative 4xi squared. And then to that, we're going to add 2x squared I. Cool. So now, refreshing your memory, I squared is actually equal to -1. And to refresh your memory on how we do that, we hit second decimal. So that gives you I, and I squared, if you hit enter, it gives you -1. So we're going to simplify this as much as possible. So the 3x stays 3x minus 2x squared I. We're just going to write that down. Plus 6i, we're going to write that down. Over here, this I squared, remember, is equal to -1. So this is negative 4x times -1 plus 2x squared I. Okay, so now we are going to combine it into simplest a plus bi form. So in order to do that, let's simplify things, right? So we have this -4 times -1 is positive 4x. I'm going to bring everything else down for right now. Minus 2xi plus 6i. And then this is plus 2x squared I. Okay. So I can't forget the squared right here. So let me just bring that down. And then, okay. So now this negative 2x squared I and this positive 2x squared I conveniently cancels each other out. Okay. And then we have 3x plus 4x. That gives us 7x. And then this is plus 6i. And it looks so far that that is going to be our answer. And it's looking good. 7x plus 6i. And I know I'm done because it's an a plus bi form. So my a is 7x, my b is 6, and my I is I. All right, that's question number 25. Question 26. So it says solve algebraically. So you can do this on the calculator, but you would not get full points for this. You would have to do it algebraically to get full points. So for the first thing we see, it's 3.8 e to the 1.5 t is equal to 16. So the first thing, like I told you as I taught this, is you have to get the weird thing by itself. The weird thing here is e to the 1.5t. So get rid of the 3.8 by dividing both sides by 3.8. Cool. And then this cancels out. So now I have e to the 1.5t is equal to 16 divided by 3.8. Let's see if that gives us a nice number. So 16 divided by 3.8. Does that give us a nice number? No, it doesn't. So I could just leave it as 16 divided by 3.8. Cool. And then to get rid of the e, how I do that is I have to ln both sides. So I'm going to ln the left and I'm going to ln the right because ln and e are opposites of each other. And as soon as they are next to each other, they cancel each other out. And so we could write down what we have left. Okay. So we have left 1.5t, because again, this canceled out, is equal to ln of 16 divided by 3.8. Cool. To get the t by itself, we divide both sides by 1.5. Divide both sides by 1.5. And then now this is something that we can put into the calculator. So t is about, and I'm going to take my calculator here, alpha y equals, to get my fraction symbol, I go ln, which is above the store button, and I'm going to put in my 16 over 3.8. So 16 over 3.8. Cool, I can close those parentheses. And then on the bottom, I have 1.5. So we hit enter. And we're going to round this to the nearest, it said hundreds. Let's just make sure. Yep, to the nearest hundreds place. So let us do that. So that is about 0.96, it looks like, right? 0.96. So t is about 0.96. So I just went through the work. And this would get you full points because we're doing this algebraically. So key thing to remember here, E and ln are opposites of each other. They undo each other. All right, question number 27. So it's asking us explain a statistical bias of the method of collection, right? So in an attempt to get a student body's opinion of a new dress code, members of the statistics class surveyed the students of the first period. So they only surveyed the first period computer science class. So they are only asking, they even though they want the entire student body, they're only asking the first period's computer science class. And so we can write the first period, right, comp sci class may not be may not be representative of the, and they want the student body of the entire student body, right? It's just a sample. So that's a statistical bias that we can have here in the method of data collection. Okay. All right. For the next one, it's a sketch a graph and they give us certain criteria. So they have zeros at -5, 1, and 4. So we can go -3, -4, -5. At -5, there's a 0. At 1, there's a 0. And at 4, we're estimating this, there's going to be a 0. And this next part right here tells us as x approaches, so x, remember, is left or right, as we go towards infinity, right? Which means that as we go to the right here, our p of x or our y is going to negative infinity, which is down. So as we go to the right, our y is going to be going down, okay? As we go to the left, right, as we go to negative infinity, our y is going to be also going down. So it's going to look something like this. So how can I take something that's like this and put this on a graph that we have that has 3 zeros, okay? So let's see. So one thing that we could do is we can say that the graph looks something like this, right? Like it has to go down in the left, so it goes down. It hits -5, and we can say it goes down like this. It comes up to 1, goes down to 4, right? And has to end going down. So this could be one representation of the graph. So anything that looks something like this, right? It hits at -5, 1, and 4. You could make it look anything like that, um, as long as it goes through those 3 points, and both on the left and the right have to be facing down, okay? Because that's what the sample says, right? Our y's are facing down, right? As we go to the right or to the left. Yeah, so pretty straightforward, I think. Question number 29. So here they're giving us a function, and they're telling us that over here, this is our function right here. So remember, this represents our midline. The A represents our amplitude. Negative cos means that it starts from a minimum and then goes up. So it's going to look something like that. And then this right here is our B. So our B is equal to 2 pi over 5. Specifically for this question, they say state the period. Okay. So for the period, we have to remember a formula. So period is equal to 2 pi over B. So we know that B is equal to 2 pi over 5, right? So you could just take this B and you could plug it in for the bottom. So this is equal to 2 pi over 2 pi over 5. That's something that we can easily take and plug into our calculator if we don't know how to simplify that. So alpha y equals, option number 1, we put 2 pi, so second up. And then I'm going to go here, we're going to get another fraction in the calculator, and we're going to put 2 pi again. So 2 pi over 5. And we hit enter in our calculator, and that gives us 5 as our answer. So our period is equal to 5. Now, what it says, state the period. So right now we found the period. Our period is 5. Okay. Now it says, what does that mean? What the period represents in this context. So that means that we're talking about a wheel and it's rotating. So it means that the wheel rotates right? Every 5, and then we have to look for our unit of time, right? So t is measured in minutes. So that means that it's every 5 minutes. So that would give you the full 2 points for this question. Okay? Every point counts. This does say solve algebraically, so if you were to plug this into y1 and into y2 and see where they meet, that would give you 1 out of 2 points, but I'm going to show you right now how to get all 2 points for this question. We have to get all denominators to be the same. Right now, if there's no denominator here, there's an imaginary 1, okay? So our least common denominator here is going to be an x and an x plus 5. You have to have both of them. So for the first one, we have only x plus 5, so we have to, what's missing here is the x. So we have to multiply the bottom and the top by x. Cool. On the second one, what's missing here, we have the x, okay, but we don't have the x plus 5. So we have to multiply both top and bottom by x plus 5. Cool. Over here, there's a 1. There's no x, nor is there an x plus 5, so we have to multiply it by both. And whatever you do to the bottom, you do to the top. Okay, so now I'm just going to rewrite down what we have. We have 8x over x parentheses x plus 5, and then we have minus 3 parentheses x plus 5 over x parentheses x plus 5. You see how our denominators are now the same. And then over here we have a 5, we have an x, and then we have parentheses x plus 5. Okay, and on the bottom, 1 times anything is itself. So this is x parentheses x plus 5. So now do you see how all the denominators are the same, right? If they're the same, I taught this lesson around Halloween, right? We slash the bottom. The only way we could do that is because there's an equal sign here. And now you could just simplify the top, so this low-key becomes an Algebra 1 question. So we have 8x, I'll do this in, 8x minus, this is distributive property, so 3 times x is 3x. This is negative 3, so negative 3 times x is negative 3x, and negative 3 times 5 is negative 15, is equal to 5x. So times x is 5x squared, and 5x times 5 is plus 25x. All right. So now we're cooking with gas. So now we have to get everything over to one side. So we're going to do 8x and a minus 3x is 5x minus 15 is equal to 5x squared plus 25x. So we have to set one side equal to 0. So we do that by subtracting 5x and adding 15 here. So whatever I do to one side, I do to the other. So minus 5x and plus 15. So now this side equals 0. Cool. So we have 0 is equal to 5x squared plus 20x plus 15. So I noticed that 5 goes into all of them. So I could just divide everything by 5 to make this a little bit easier. So I don't have to use AC method. So 0 divided by 5 is 0. 5x squared divided by 5 is x squared, plus 20 divided by 5. This simplifies to 4x. And then last, I have 15 divided by 5, which is positive 3. Okay. So now I'm looking for two numbers that add to be 4, multiply to be 3. So they multiply to be 3 and add to be 4. What are they? Cool. 3 and 1, right? So our double bubble is x plus 3 and x plus 1 equals 0. So just like we did in the part 1, we're going to set both these equal to 0. So subtract 3 from both sides and I get x equals negative 3 is one of my answers. Do the same thing with the other side and I get subtract 1 from both sides, I get x equals negative 1. So my two solutions are x equals negative 3 and x equals negative 1. And then last step here is we have to check and see if I plug it back into the original, wherever it feels like coming up. Cool. When I plug it back into my original, am I going to have any undefineds, right? Undefined means that the denominator is equal to 0. So if I plug in negative 3 plus 5 is 2. That's not going to give me a 0, so that's good. If I plug it in here, that's still okay. And if I plug in negative 1 plus 5 is 4, and negative 1 is here. So both of them work. And I can check that with the calculator as well if I plug this into y1 and this into y2. But for this question, both solutions work, so there are no extraneous solutions, so I'm good. Okay, question 31. So first thing we want to do when we see a question like this, when we're looking for independence, is we want to see if we have any totals. We want to total things up. So let's total up. 58 plus 75 plus 12 is equal to 145. 81 plus 39 plus 12 is equal to 132. Cool. And then I want to total these up going down. So 58 plus 81 is equal to 134. No, 139, my bad. It was like 8 plus 1 is not 4. And then 75 plus 39 is equal to 114. And then if I add 12 and 12, that gives me 24. And then when I add all my totals up together, I get 277. Okay, so if I went 145 plus 132, that's 277, or 139 plus 114 plus 24 is also 277. All right. So now I can see if there's independence, right? So are the events being a junior, so the probability of junior, and driving to school independent? So if I have the probability of being a junior, given that they are driving to school, if these two numbers are different, then they are not independent. So if these two numbers that I have are different, that they are not the same, then this means that they are not independent. If these two numbers are the same, then they are independent. Okay, that's how you tell if something is independent or not. Is if you have one of them by itself, whatever that is equal to, and then if that's equal to the probability of that same thing being a junior, given that they are junior and driving to school, or given that they're driving, then those two things are, if they're equal, then they're independent. If they're not equal, then they're not independent. Okay, so that's how you tell. So let's see, what's the probability of being a junior? So let's see what that means. Okay, so the probability of being a junior. How many juniors are there, right? So if I were to take the amount of juniors altogether, that's going to equal to 145, right? So there's 145 juniors altogether out of the 277. So 145 out of 277. If I were to take that and put that into the calculator, 145 divided by 277, let's see, divided by 277, that is equal to about 0.52. So this is 0.52. Okay, so now I want to see the probability of being a junior given that they are driving to school. Okay, so remember the formula for a given is probability of junior and driving to school over whatever second, right? The probability of driving to school. Okay, how many total drive to school? So how many juniors drive to school? That's what this means, right? Probability of junior and D, right? So juniors who drive to school, let's see what that looks like. Here are the number of juniors. Here are the people who drive. So the one that overlaps in both is 58. So 58 are juniors who drive. That completely makes sense, I hope. Okay. And then we want to look and see the probability of people who drive altogether. Right. Let me just put this 145 down. Cool. How many drive to school altogether, right? So the people who drive to school altogether are just these, which is 139. So 139 goes on the bottom. And so this is something that I can also plug into my calculator, right? I have 58 divided by 139. I hit enter. Okay, look, those two numbers are different, right? 0.52 and 0.148, no, 42, 0.42 are different. So this is about 0.42. Those two numbers are different, which means that the answer, are they independent? The answer is no, right? Why? Because, right, these probabilities are not equal to each other. That's why they are independent. They are not independent, okay? If they were the same, if 0.52 and 0.42 were the same number, like it had both 0.42 or both 0.52, then they would be independent, but they are not, okay? That means that driving has an effect on probability of being a junior, okay? All right. Next question, 32. So can f of x equals x to the third plus 7 be classified as an odd function? This is a throwback, right? Even functions are symmetrical with respect to the x-axis, which means that if I fold it along the x-axis, they are going to be the same. Odd functions are if I take my paper and I turn it around 180 degrees, they're going to look the same. It has to go through the origin. So let's see if this happens, right? Let's go to y equals and let's clear what's there. Cool. And let's type in x to the third plus 7. Does this go through the origin? And nope, it does not. So we could say, we can sketch our function. It's going to look something like this. Did I do a good job? Not terrible. Okay. So we could say, can it be classified as an odd function? And it says justify. So no, right? Because a 180-degree rotation, right? If you flip it 180 degrees about the origin, does not map f of x onto itself, right? Or it's not the same if you onto itself. It's not the same if you were to take it and rotate it 180 degrees. They would not look the same. Okay, so that's our justification. We happen to explain in words. All right, cool. So that is part 2. Those 8 questions are worth 2 points. This one says solve this function algebraically. I want to remind you that if you hit apps and you went to polysymbol 2, and then you went and did simultaneous equation solver, this would give you 1 point out of 4, right? This is going to 3, going over here to 3, and plugging in, go to next, and plugging in these numbers, right? So instead of 3x, you're going to plug in 3, then go over to the next, or hit enter, -8, hit enter, 2, enter, -60, enter, right? You see what I'm doing? 2, and again, this will give you 1 point, but listen, 1 point is better than no points, right? -31, cool, and then -6, enter, we're going 2, we're going -4, make sure you plug it in correctly, hopefully I did, and then you're going to hit solve, which is graph, and you get your answers. So x equals -2, y equals, let's see, 6, and z is equal to -3. All right, so if you just did this, this would give you 1 point out of 4. How do you get all your points? Okay, you get all the points by doing this algebraically, which means that we got to get rid of one of these like variables. Okay, so pick any 2 that you'd like. So let's say I pick these 2 right here, the 2 bottom ones. And if I right now, if I add them, none of them are going to cancel each other out. But if I take the second one right here and I multiply it by 3, I'm going to get 6x minus 21y minus 15z is equal to 3 times -31 is -93. And now if I add that to the bottom one, which is -6x plus 2y minus 4z is equal to 36. If I add these babies together, these are going to cancel out, right? And I'm going to get -19y minus 19z is equal to negative 93 plus 36 is going to give me negative 57. All right. So that is me using the two bottom ones. So I cannot use the two bottom ones again. Okay, so I have to use either the first one and the third one, or right. So let's see. So what can I do now to figure out how do I get rid of some more x's? Okay, so I see that if I use these two, the first two, the first one and the last one, let me see if I can do this in a different color. If I use the first one and the last one here, I have to still get my x's to cancel out, and I can do that by multiplying this by 2. So let's see what happens if I do that. I get 6x minus 16y plus 4z is equal to negative 120. Cool. And then I bring down the bottom one, so negative 6x plus 2y minus 4z is equal to, if I yeah, cool. So now, if I add these together, 6x minus 6x cancels out. This cancels out. This is good. So now I have negative 14y is equal to negative 120 plus 36. So what is that? 120 minus 36 is going to give me, this is going to give me negative 84. Cool. So I'm almost done. So now I can get the y. I divide both sides by negative 14, divide by negative 14, and 84 divided by 14, this is going to give me 6, so I know y is equal to 6. So far right now, I have one of them. Cool. So now I can take my y equals 6 and I can plug it in here, right? So I have negative 19, right? And instead of y, I'm going to plug in 6 minus 19z is equal to negative 57. So let's see what z is, right? 6 times negative 19 is going to give me negative 114 minus 19z is equal to negative 57. So now let's move things over to the other side, right? So I have plus 114 plus 114. This is going to cancel out. So I have negative 19z is equal to 114 minus 57 is going to give me 57. All right. And then if I do 57 divided by negative 19, I'm going to get z is equal to negative 3. So I got my y, I got my z, and that confirms what I have here. Now to get my x, right, I can plug in into any of them, into the first one, the second one, or the third one. Why don't I just plug it into the first one just because it looks pretty straightforward. Cool. So I have 3x. I don't know what my, oh, I should do this in a different color. Okay, so you see what I'm doing to get my x. So I have 3x. I don't know what my x is. Then I have minus 8y. Instead of y, I'm going to plug in the number 6. And then I have plus 2z. Instead of z, I'm going to plug in negative 3 is equal to, and this is equal to negative 60. So I have 3x minus 48 minus 6 is equal to negative 60. And let me solve that. So 48 and 6, that's going to give me 54. So 3x minus 54 is equal to negative 60. Add 54 to both sides. I get 3x is equal to 6. Correct? No, negative 6. Yep, negative 6. And I got that by adding 54 to both sides. Forgive me for skipping some steps. And then divide both sides by 3. And I get x equals negative 2. So I found all three of them, x equals negative 2, and that matches with what I had. So I'm done. All right, nothing crazy. Question 34. For this one, this is a straight calculator question. Average rate of change. So I'm going to go here. Let's quit this. Let's go to our main. Quit this app. I'm going to just reset my calculator. Second plus 712. And I'm going to go to my y equals, and I'm going to type in my function. So I have 200,000 parentheses 1.045 close parentheses to the, instead of t, I'm putting x. And then I'm going to go to my calculator, right, to my table. So it's asking me for the prices from 2010 to 2018. And so h of t, right? It says t is the number of years since 2008. So this right here is where t is equal to 2 because 2010 is 2 years after 2008. And this here is where t is equal to 10, right? Because 2018 is 10 years after 2008. So I'm looking for the average rate of change, right? Remember this formula? Y2 minus Y1 over X2 minus X1. Okay, cool. So my X1 is equal to 2 and my X2 is equal to 10. So I'm going to put this down, right? 10 minus 2. And then to find my Y values, I'm going to go across from the number 10. So across from 10, I have 310594. So 310594 minus, and then the number that's across from 2 is 20900. So 20900. And then this whole thing just literally just goes into the calculator. So I hit quit. Alpha y equals option number 1. Let me move this over here so I can see it. So I have 310594 minus 20900, and then 10 minus 2, which is equal to 8. Okay, and then I hit enter and I get an answer. ¿Qué pasó? Let me just check and make sure that I plugged everything in correctly. Is this 200,000? So 200,000, and I went over here. So let me just check the number across from 2. Oh, across from 2 is 218405. 218405. Let me check that. I'm glad I checked it. 218405. All right, so now let me go back to my calculator. I'm going to go up, and instead of typing the whole thing again, I'm literally just going to change my second answer to 218405, and then I'm going to hit enter. Okay, much better. So now I get that my average rate of change is about 11,524 because it says to the nearest dollar. So let's see if that makes sense. That does, because that 6 makes the 3 go up. Cool. So that's how much the average rate of change is, and this is money. So this is in dollars. Okay. So then it says explain what this rate of change means as it relates to house prices, right? So we could say from, and our years were 2010 to 2018, the median house price increased, forgive my handwriting, $11,524 per year on average, or an average of $11,524 per year. Okay, so that's our explanation. All right, we're getting there. Question 35. Cool. As soon as you see middle 95%, you got to think of the formula mean plus or minus 2 times standard deviation. So our mean is right here, right? We have 0.795 plus or minus 2 times our standard deviation, which is 0.085. So this is a straight calculator question, right? 0.795 minus 2 times 0.085. Hit enter, we get 0.625. So that's our lower number. So this is 0.6252. And then our upper number is going to be, I'm going to take the same thing. Why is my calculator doing that? Cool. I'm going to go up and grab this. And instead of the minus sign, I'm going to put a plus sign. And I hit enter, and the largest number is 0.965. So that's the middle 95%. Okay. Then it says we want to see if it's probable. Using that interval, explain whether or not the company should continue to produce both types of hockey pucks Um, and we could say it's reasonable is above 0.60. So is, sorry, just got a text. The company will contribute this if it's reasonable to assume that the true proportion who buy both types is above 6.60. Yeah, so if it's above 0.60, using the interval for part A, explain whether or not the company should continue to produce both types. And the answer is yes, right? It is, because this interval is above 0.60. So yes, and we could say as it is probable, at least 0.625 of the customers will purchase both. Okay, not bad. Question 36 is a straight calculator question, but there is one catch. Okay, so I'm going to go to y equals, I'm going to clear what's there. I'm going to type in the function, which is log base 2. So to do that, we have to hit math. We have to go all the way down to log base. So log base 2, parentheses, and this is x minus 1. And then we go over here and we put plus 3. So now watch. Okay, I'm going to hit graph. So I want to try to get as exact as possible, but I notice at 1, the graph kind of like cuts off, right? A little bit. So this is what we have to do. We have to go to graph. Let's look for some good whole numbers. So we have 2, 3. So 2 and 3, there's a dot there. Okay, another good one is 3, 4. So 3, 4, there's a dot there. Another good one is 9, 6. So 9, 1, 2, 3, 4, 5, 6. So 9, 6. Okay. So right here, I'm going to just zoom in a little bit. So I can see that the graph is going to go something like this over here. And then, right, between 1 and 2, it's going to go like this, right? It's going to go down. And I have to show that I know that the graph, and forgive me for doing it like this, I want to try to make this as smooth as possible, goes between 1 and 2. And I want to show that I know that it keeps on going, right? It's going to keep on going down, but it's not going to cross over 1. And how do I know that, right? I know that because if I look over here at if I look at my graph, right, you see how it doesn't ever go to 0 and it doesn't go to the negatives. It just kind of like stops right there. And so that tells me that there's an asymptote there. An asymptote, remember, is a line that the graph never crosses. So over here, it keeps going in this direction. And it's going to actually ask me about that over here, right? So it says state the equation of the asymptote. So the equation of the asymptote is right here. Let me do this in a different color. I'll do this in blue. So the graph never crosses 1. You see that? So what is the equation of that line, of that asymptote? The equation of that line is x equals 1. It never crosses 1, where x equals 1. Y equals 1 is a horizontal line. We don't have a horizontal line here. We have a vertical. So it's going to be x equals 1. It's the opposite of what you think. Okay. So it says when f of x is reflected over the line y equals x, a new function is formed. So that's called the inverse. Then it says state the equation of the asymptote of g of x. Okay. So what does that mean? If I have my function, which whenever it feels like working again, it's going to work. Okay. If I were to take this and if I were to do the inverse of this, right, that means that I'm going to flip it over the line y equals 1, y equals x. So that is y equals x is a line that looks like this. See what I'm doing? Okay. So if I take the black line and I flip it over the line y equals x, it's going to look something like, if I were to graph this right here, let's see. Like I have the function. So 2 to the x minus 3. And then I'm going to go to the right and I'm going to put plus 1. So what's my equation of the asymptote here? So, okay. So it looks like, you see that? You see how they're both inverses or opposites of each other? So the asymptote here is the line y equals 1. It's a horizontal line. Okay, so my new line is going to be, the asymptote is going to be at y equals 1 because it never crosses to 0. And I can prove that by going to the table, looking at the red graph on mine, and it never, you see how these numbers right here, right? It gets close to 1, but it never crosses that, right? And I can show you by going up. See these, the numbers in red? That approaches 1, gets very, very close, very close, very close, very close, very close. And then it says 1, but what that really means is that it gets very, very close to 1. But it never goes to 0 or negative. So that's my new asymptote. All right, question 37. This question looks crazy, but it's not. I'm going to show you right now. Okay. So as long as you read, it says the liquid temperature, the temperature of the liquid is 112. So if you look over here, that is exactly what T of T is. So this number right here, we're going to put in 112. That's what we write. Okay, that's our T of T. Then our TA is the air temperature. And if we read that, it says the air temperature is at 73. So instead of, right, this TA, instead of this number, I'm going to put in 73. Then I put a plus sign, and then I put parentheses. Then my T0 is my initial. So what is the initial temperature, right? And the liquid is 237. So this right here is my initial. So I'm going to put my 237 here. Then there's a minus sign. So I'm going to put my minus sign. And then I'm going to put my TA again. So my TA was 73. And then it says you got to put the E. So we put the E. We don't know what the K is. So I'm going to put, we're not really sure what K is. So I'm going to leave that number alone. And then the T, it tells us that if we look at it, it says 1.5 hours later. So my T is 1.5, so minus 1.5, because 1.5 is 1.5. And if you look at the question, it says it's negative, so whatever the T is, make it negative. So I just did that, okay? So now we have to solve this, okay? Determine the value of K to the nearest thousandths. So I have to solve this equation. I could do it algebraically, or I could do this on my calculator. So let me show you how to do this on my calculator. Second plus 712. Let me get rid of that. And this is not saying algebraically, right? Nowhere in the question does it say to do it algebraically. So I can go to here. I can go type in 112 under my y1, right? That's whatever's on the left side of my equal sign, right? So I plugged in y1 here, and I can plug this whole baby in under y2. So I have 73 plus parentheses, right? 237 minus 73 again, close parentheses. Then I have E, so second ln, and then I put negative 1.5, and instead of K, I'll put X. Okay, now I hit graph. So I want to see where these two lines, the 112 and my function, where they meet. Okay, so far right now it looks like nothing's graphing. And the reason why is because 112 is very high, so I have to hit window. And my y max, I want to change it to a number that's bigger than 112. Okay, so let's just go 120. Let's see what we get. Okay, cool. There's my 112. And now do I have my function? Okay, there we go. There's our function. So now I'm looking to see where those two lines meet. So I hit second trace. Option number 5 is intersect. I'm going to go over to the right till it meets around there. Enter, enter, enter. And I'm going to get my answer. So 0.95, it says to the nearest thousandth. So I have K is about 0.958. Okay, that's my answer. Now, what if you didn't know how to do that? Okay, what if you wanted to do this algebraically? How would you do that? So first thing we could do is we could do 237 minus 73. Cool, so that's 164. So I can have 112 is equal to 73 plus, we just figured out that this is 164 e to the negative 1.5k. Okay, so I want to get everything over to one side, so I can subtract 73, right? Remember, let's get our weird thing by itself right here. So subtract 73 from both sides. So 112 minus 73 is 39. So I have 39 is equal to, this cancels out, 164 e to the negative 1.5k. Cool. Now I have to get my weird thing by itself by dividing 164 like we did before. So 39 divided by 164 is probably going to give me an ugly decimal, and it does. So that this cancels out. So I'm left with e to the negative 1.5k is equal to, I'll leave this as 39 over 164. And like I did before with the problem, right? I'm going to ln both sides. So ln the left, ln the right, and these cancel each other out. So ln of 39 over 164 is equal to negative 1.5k. To get the k by itself, I divide both sides by negative 1.5, divide by negative 1.5, and now I'm left with k is about, and this is something that I can go to my calculator for, right? It should give me the same exact value. So I have alpha y equals option number 1, right? I'm going to put in ln of, get our fraction again. So 39 over 164. And I go down and I put in negative 1.5, and look at my answer. Same answer that we got before. This is about 0.958. So either way you do it, you still get the same answer. Okay, same answer. All right. So the next one says determine the temperature of da 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 using your value for k. So now we're going to use that value to the nearest degree after 2.5 hours. Okay, so now we have 73. It's still 73, but I use my same formula, right? So this right here. So 73 plus parentheses, it's still 237 minus 73. It's still e to the, now it says use your value of k. So I had negative 0.958, and then it says after 2.5 hours, so 2.5 hours, this gets multiplied by 2.5. Okay, and now this is something that this whole thing we can plug into the calculator, and this is going to give me about 88. It says to the nearest degree. Okay, so you can plug that into the calculator and you can see that this gives me about 88. All right, so for the next one, it says Megan needs the temperature of the liquid to be 80 degrees. So we want 80 degrees to be the answer, right? Before it was 112. To perform the next step in her experiment, use your value for k. So they want us to use that negative 0.958 again to figure out what our t, how much our time is. Okay, so 73 plus still 237 minus 73. It's still e. Don't forget that. It's negative 0.958. And now we have to figure out what our t is. And just like we did before, we can use our calculator. So we can go to y equals here. And instead of 112, let's plug in 80. And then let's just make sure that we have the rest of this correct. So 73 plus 237 minus 73. E to the, and we're going to change this, right? So we have negative 0.958, and then we're going to put x. And let's hit graph, and we want to see where these intersect. So 80 is going to be a straight line whenever it feels like it. Did I not plug in the 80? Oh, I did 802. You see, I knew something was wrong. 802. Okay, so now I'm going to see my straight line for 80. I'm going to see my function in red, and then I'm going to look to see where those two things meet. Cool. So I'm going to finish letting it graph, and then now I'm going to hit second trace, option number 5 again. I'm going to go over to where they meet, so somewhere as close as possible. This is our last question. Cool. So this is about 3 point, and it says to the nearest tenth of an hour. So that means that t is about 3.3 hours. Cool. We're done. That's it. All right. Good job.